So let's do a practice problem. A tank holds 1,000 gallons of water, which drains from the bottom of the tank at this point. In an half hour, 30 minutes, the value in the table show the volume V of water remaining in the tank in gallons after t minutes. So we have t minutes, so 5 minutes, we have that much left. 10 minutes, we have 444 gallons left. 15 minutes, 20 minutes, 25 minutes. At 30 minutes, we have nothing left. And then part A, if P is a point 15 to 50, so this is a point right there. Let's highlight that. So they don't let me do it. Okay, I will just write on it. Okay, so that is my point P. On the graph, find the slope of the secant line PQ, where Q is the point on the graph. T equals to 5, 10, 20, 25, 30. So basically there are 6 points on the graph. We treat this point as P and every other point as a Q. So that means in part A, we have this point P is 15, 250, and then point Q is 5, 694. We have a point P, we have a point Q. The question is asking you to build a secant line and then find the slope of the secant line. So if you look at the bottom of the problem, I have some reference right there. So the picture and the table makes everything more organized. But I still want you to do the work to get the numbers. So this one, the slope, don't just take it from me. This one, I put the graph right there because this is easier to read. If I draw this on my iPad, the surface is so slippery, it is very hard to draw a good picture. So let's go back to the question. So in part A, what they want me to do is they want me to do a secant line. PQ. So we have 2 points, that is enough to build a secant line. So what is the slope equals to? The slope is equals to y2 minus y1, 694 minus 250 divided by 5 minus 15. So that is negative 444 divided by 10. We divide them, that is negative 44.4 gallons per minute. All right, and then the next point, we take the 10, 444, so P is 15 to 50, and then Q is 10, 444. We do the same thing, we do another secant line. So the MPQ is 444 minus 250 divided by 10 minus 15. So we have 194 divided by negative 5, that is equals to negative 38.8 gallons per minute. And then we keep going. So this is negative. What does that mean? Negative means the water tank is losing water. Okay, negative 38.8. So between these 2 points, point P and point Q, the tank is losing water at 38.8 gallons per minute. And then the next point, we have 15 to 50, and then the other point is 20, 111. So that is my point Q. We do the math. The slope is equals to 111 minus 250, and then 20 minus 15. I will just give you the decimal. So that is equal to negative 27.8 gallons per minute. All right, so after you are done, can you keep these numbers for me? Because this number, they are what's right here. They are what's right here. I'm trying to give you the number instead of saying, okay, hey, here is the table, take it. I don't want to do that. I want to show the work and then give you the result. And then the next one, okay, scroll down. So we have P 15 to 50, and then Q is 25, 28. So we are almost there. 25, 28. So MPQ is 28 minus 250 divided by 25 minus 15. So that is negative 22.2 gallon per minute. So as you can see that the water is leaking at a slower speed. And then the last one, 15 to 50, and then we have 30, 0. So Q is 30 comma 0. And then we do the same thing. So we have MPQ equals to 0 minus 250 divided by 30 minus 15. So that is equals to a negative 16.6 gallon per minute. So these are the numbers right here. So that is your part A, and then in part B, estimate the slope of the tangent line at P by averaging the slope of two secant line. So this one, averaging the slope of two secant line. So this one we have to pick two secant. So let me change colors for that. Let's use blue. So I am going to pick two pairs. The first, in part B, the first pair I will pick is 15 comma 250, and then the Q I will pick 10 444. What is the slope? So the slope is negative 38.8, right? And then the other pair I will pick P 15 comma 250, and then Q I will pick a 20 comma 111, because that is on the neighborhood, right? So we have 10, 15, 20, right? So I want to pick them, and then I'm going to take the average. So let's take the average. So the average is, so I'm going to call this average is equals to what is this? The is right here, right? So that is a negative 27.8. So the average is negative 38.8 plus negative 27.8 divided by 2. You calculate the average. That is around negative 33.3 gallons per minute. So that answers B. And then what are they asking in C? C is you use a graph of the function to estimate the slope of the tangent line at P. The slope represents the rate at which the water is flowing from the tank after 15 minutes. This one, the first thing that you have to do, if I draw a graph, the graph will be very messy. I can try my best to draw one for you. So for part C, to draw a graph, first we have to draw a vertical axis and a horizontal axis. So this one is a minute, is in T, and then this one is the volume at gallon. So the time period they mark at 5, 10, 20, 25, and 30. So that is where they mark the time. And then the graph, if I just give you plot 6 points, the graph is not going to look good. So I will try my best to copy the picture for my reference over here. So at the very beginning, you have 1,000, right? So at 5, how much do you have at 5? At 5, you have 694. So 694, almost 700, right? 694, and then at 30, you have a 0. This is not a straight line, so this one looks like a curve. I will try my very, very best to draw a curve. So if you plot all the points and then connect them, you will see a curve that looks like this. So at 10, at 20, at 25, and then at 30. So you have 5 points, not 6 points. And then which one is my point P? My point P is they took the one at 15. Oh, did I miss one? Oh yeah, I missed one. That's why they are. Okay, how do I fix this? I think the best way to fix this is we erase some numbers right here, and then I can redo the line, and then 5 at 10 at 15 20, and then 25 and 30, and then we erase the line a little bit. I can draw another one for you. Don't worry about that. So we draw another line, make sure that looks like a curve, not a straight line. All right, and then the point P, they use 15. Okay, so 15, I'm going to use another color for that. Let's use red. So the point they use 15, and then at this point, this mark is 15, and then a 250. So this is my point P. And then they take 2 points, one at 10 and then one at 20, right? So the one at 10 is this, the one at 10, and then the one at 20, this is a curve, not a straight line, although that looks like a straight line. So what they are doing is, at point P, there is a tangent line. At point P, there is a tangent line. I'm going to stick with the color at point P. So there is a tangent line right there. And then what are they asking? Use the graph of a function to estimate the slope of the tangent line at P. All right, you can do that. So this one, let's go back to the green. The green between 10 and 20. Between 10 and 20, so we have a rise between 10 and 20, and we have a run, and then this is a rise. So if you take the rise over run, they should be around that slope. What's the slope? The slope I got from the previous one is negative 33.3, right, from the previous problem. So the slope, let's drop the slope right there. So the slope from the previous one, yep, right there, is around negative 33.3 gallons per minute. So what we are trying to do here is, I see what they are asking. You are not going to take this green point, because if you sketch a straight line, so let's go back to red. If you sketch a straight line, the straight line is not going to touch those two green points. If you sketch a straight line, the run is actually equals to 9. And then the rise is approximately 30. So when you do 30 divided by 9, this is around negative 33.3. The reason we use negative is because the tangent line is going downhill. The red line is going downhill. And then at 10, what table value do they have? At 10, I see. So for the red, so at 10, if you take a mark right here, this is approximately 400. And then the mark right here, this is approximately 100. So this is approximately 100. So 400 minus 100, you get your 300. And then at this point, that corresponds to 10. And then at this point, that corresponds to 9. A point from here to here. This distance is around 9 units. So that's why we have 300 divided by 9. So this is pretty a weird problem. I don't think you will see that on a test. So let's go ahead and take a look at the next problem. So the next problem, we have ball in the air. So ball in the air, let's read the problem. If a ball is thrown into the air with the velocity of 400 feet per second, the height in feet t is height in feet t seconds later is given by y equals to that, and then so t is equals to time, y is equals to height, right? So this is actually a position function. find the average velocity for the time period beginning when t is equals to 2 and lasting 0.5, 0.1, 0.05, and 0.01 seconds. Okay, so we start with the position function, and then this is actually a time window lasting 0.5. 0.5 means you start at 2, you add 0.5 to it, that is equals to 2.5, so that gives you a time window. So we start with a position function. I don't like writing the functions like that. I would like to do this. Y is equals to y of t, that is equals to 40t minus 16t squared. So the t is equals to time. And then when t is equals to 2, let's don't use red for this. When t is equals to 2, this is part A. When t is equals to 2, we have y of 2 equals to 40 times 2 minus 16 times 2 squared. That is equals to 16 feet. And then to build a time window, this is something that you have to learn. The average velocity is change in position divided by the time elapsed. The time elapsed, you have to do a time window. So for the average velocity, you have to do this. This is a velocity and then average. So that is equals to y. And then we have to do, look, 2 plus a little bit of time ahead minus y of 2 divided by 2 plus h minus 2. So the plus h is the time elapsed. You have to add a little bit of time ahead, just like this. You have to add 0.5 ahead. So 2 plus h is something you have to plug in into the position function. So you plug in 2 plus h. You plug in 2 plus h to here, to the t. So after you plug it in, you have this. You have 40 times 2 plus h minus 16 times 2 plus h squared. And then y of 2 is 16. We just got it right here, so 16. And then the bottom, 2 plus h minus 2 is just equals to h. This is something that we will have to use. And then, what did they ask? We need 2 points. So we need 2 points. So point 1 is 2 comma y of 2. You plug in 2 to the position function to find the y value. And then point 2, you have 2 plus h, and then y of 2 plus h. 2 plus h is the time elapsed. You want to build a time window. So let's say now the time is at 0. 5 seconds later, you want to add 5 to it, right? So the plus h is the length of the time window. Okay, and then you have to plug in, right? So 2 points. So it's actually not a plug-in. Is you have to fully simplify. So you have 80 plus 40h minus 16 times 4 plus 4h plus h squared minus 16 divided by h. And then clean up the top. You have 80 plus 40h minus 64 minus 64h minus 16h squared minus 16 divided by h. Are we able to cancel some terms? Yes, the 80 minus 64 minus 16 can be cancelled. And then the rest, we have 40 minus 64. And then the h squared cannot be cancelled, minus 16 h squared divided by h, get rid of the h. So average velocity is equals to negative 24 minus 16h. You factor out the h and then delete the one in the denominator. So now we have the average velocity function. We are able to take care of the time window. So the first one they gave you is 0.5. So the time window is from 2 to 2.5. and then the average velocity is equals to negative 24 minus 16 times 0.5, that equals to negative 32 feet per second. And then the next one is h equals to 0.1, so it looks like they are trying to make the time window smaller, 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 and smaller. And then this is a 2.1, so this is V average equals to negative 24 minus 16 times 0.1, that is equals to negative 25.6 feet per second. And then h equals to 0.05, we have 2 comma 2.05, and then the average velocity is negative 24 minus 16 times 0.05 equals to negative 24.8 feet per second. And then the last one, average velocity is negative 24 minus 16. I haven't given you the last one yet. It's 0.01. So you start at 2 and then you step 0.01 forward. That is 16 times 0.01 equals to negative 24.6 feet per second. So that answers A. And then in part B, what did they ask? In part B, they said estimate the instantaneous velocity when t is equals to 2. So when t is equals to 2, the instantaneous velocity is equals to negative 24 feet per second, because this, look at this time window. This time window is getting so tight, right? It's almost from 2 to a 2 point a little bit more. So if you do a 2.001, this number is something that is very close to negative 24 feet per second. So overall, at t equals to 2, the instantaneous velocity is just negative 24. So what they are doing is they are trying to take two numbers. Actually not two numbers, 2 points, from 0.1 to 0.2. This is a 2, this is a 2.2. This is a 2.5 initially. And then they are trying to shrink the distance between these 2 points to like this, from 2 to 2.01. And then they want to find the slope between them. So it turns out that as the distance between 2 points are closer, closer, and closer. So this is like a secant line, right? So this 2 point is like a secant line, a line that goes through 2 points. So as the distance are getting closer and closer, the slope is getting closer and closer to negative 24. So that is what you are trying to do. So the negative 24, you can treat that as the slope of the tangent line at 1 point. But in order to get to this 1 point, we have to start at 2 points. Start at 2 points, make the distance small, shrink the distance from this big to this small to see what happens to the slope. So it turns out that the slope is getting closer and closer to 24. So that means as h, get used to this symbol. This is not an arrow. This symbol means approach. As x approaches to 0, the average velocity approaches to negative 24 feet per second. So that brings you to a very important symbol that we will be using in the future. This arrow in differential calculus, especially in limits, that means approach. So when you see this arrow in the future, that means approach. Alright, so that will be all in this lesson. I will catch you all in the next one. Alright.